Yo. Okay. So CP, whatever this is, CPA. Yeah, CPA video. Um, we did a lot of research, honestly. It's all on exceptions, right? So here, that doesn't show. Oh, there it is. So like in the catch, you want to add like an exception to make sure what it's caught, right? So this one's a future error. So if there's a future error in this try, which there is going to be because this is an example of why to get the future error. Oh yeah, because it's like promising there's an empty function, but there's nothing. It doesn't define what empty is in the function. So that's what caused the future error. But anyways, it catches that because you're trying to catch a future error. And that's what it runs. The reason why you want to do the specifics is because you can throw a different error code or throw any like message or whatever, depending on what kind of error it is. Now what you can do is catch and then 3 periods to catch all errors. Which yeah, you can do that, but you don't you won't know what causes the error. You just know there's an error, right? So that's pretty much what exceptions are. Pretty like just some background information. So basically, I think the biggest thing we worked on, not worked on, but like learned, is smart pointers. I went down a really big rabbit hole of just researching because like I had to look up find bad weak PTR, right? So then I had to know what shared pointer was, and expired weak pointer is. So like first I went to expired weak pointer, right? And then you do here, right? And it's like, oh, it's a weak pointer that's just expired or something. And then you're like, well, what's a weak pointer? And then it's like, oh, it's like a shared pointer. And then you're like, cool, what's a shared pointer? And then it's like, oh, it's like it's a smart pointer. And now you're like confused because it doesn't really tell you what's going on. Anyways, I figured it out. Smart pointers are basically pointers that delete itself after um, a set time, not a set time, but like a set. What am I trying to say? Like out of its scope, right? Um, this is good because it makes it so um, there are no memory leaks in your code, so that's nice. There are very rare times where you want to use a raw pointer, apparently, and I've only been using raw pointers, so I should probably start switching to this. So basically, let's go over shared pointers because I think that is the coolest out of the three that are available: shared, weak, and unique. I think I can go over weak pretty simply. Well, actually, I have to because I have to talk about bad weak PTR because that's the exception. So pretty much, I have this example pretty much in right here, right? I can change this to hello just so it's easier for you to see. So basically, I have to include memory in here because I'm using pointers. You don't have to do that with raw pointers. Um, so I guess that's a difference. But you have to include memory, right? So pretty much what a shared pointer is it's a pointer, right? That deletes itself out of its scope. And these are scopes, right? So like this is a scope, this is a scope, this is a scope. Pretty much I didn't know this before, but you don't have to have stuff before it, right? You can just have this and then it's a scope, which is cool, I think. Right? Okay. So I have a very basic class of a constructor saying hello and a destructor saying bye, right? So this is important for you to know when it destroys itself um, outside its scopes, right? Okay. And then I use this cn.get to you might notice that I don't have a get function. It's a function that's inside C++, which is cool. Anyways, um, so yeah, this is important so you know like at what point does it get destructed, right? So shared pointers are pretty cool because they're smart pointers that can share its stuff, contents, information. See, so I have a shared pointer named shared here based off of the A class, right? That's what this is. Make shared A. And then I'm saying E is another shared pointer right here. See that? This okay, I'll get back to this, but I'm saying shared pointer E here, and then E equals shared. So basically E is the same as this. And shared pointers have what's called a reference pointer. And this is what makes it cool is a unique pointer um, can only have there's can't be any references to it. That's why it's called unique. It's basically like a baton. It passes the information as soon as you say I believe. Now I'm not 100% sure on this. I believe you can still say like E equals shared. However, as soon as you do that, shared gets deleted, right? So it's like passing it. If you can't, then it throws an error, and I'm not sure because I haven't really gone into too deep into unique. I'm pretty much I've pretty much scratched the surface, which is scary because I've spent 2 days on it, maybe three. So yeah. Anyways, uh, sorry. Anyway, so reference pointer. As soon as there's 0 references, the shared pointer gets deleted. But if there is still one reference to that shared pointer, it does not get deleted, right? So pretty much this is what that's showing is um, if I only have here, I can just change this. So basically, I just have an empty shared pointer. That's not going to do anything because it's not saying it's from class A yet. So pretty much, I have one shared pointer named shared that actually goes to the class, and it's by itself in the class. So basically, this is what smart pointers do. It says, okay, I can change it to show you exactly that it's actually doing it. So pretty much, it says hello. It's waiting for my input because I am in that scope. And as soon as I get done, and it's going to go out of that scope, right? It says bye because it's out of its scope. That's what smart pointers do. Okay, now I can show you the thing that shared pointers do, right? It says hello again. Wait, I actually can show you better if I do this. So it's going to ask me twice to do input. So it's saying hello, and this is the first um, CN asking for user input. So I do that, and then it asks it again without deleting it. So pretty much, this original one has been, I don't know if you want to say deleted, because it's technically has a well, yeah, okay, yeah. Shared is deleted, but the reference to the class that E has from shared is still there. So there is still one reference to the A class from shared available. So the A class is not the yeah, this the A class with the pointer has not been deleted, destructed. So that's why the destructor has not been ran. And as soon as I get out of this scope, because I start shared pointer E, um, in this scope, I initialize it in the scope, and then I just set it in the scope. That's why this scope matters. So as soon as I get done with this, it says bye. And weak pointers are pretty similar to shared pointers. However, weak pointers do not increase the reference counter because, and the reason it makes sense because weak pointers you cannot get out of its scope. You can't do um, you can't. Sorry, my phone's going off. There we go. You can't do this. You can't say, okay, I'm gonna make a shared pointer and here's E. You can't do that with weak pointers. That's why they're called weak. Pretty much, you can say, okay, let's say I initialized a weak pointer in this called E inside the scope. And I would say E equals shared. You can do that, right? The reference counter does not go up because it has to say inside the scope, right? And uh, so yeah, that's pretty much the difference. It's not recommended to keep information inside the weak pointers because they are weak, as the name suggests. But yeah, the reason why you would want to use a weak pointer is because they're faster than shared pointers. It has less information. Um, and then if you only need to use it if you want to make sure it only has one reference, you want to use a unique pointer. And also it's faster than shared pointers because it only has to deal with one reference. But yeah, so pretty much bad weak PTR is thrown when you have a shared pointer constructed with an expired weak pointer. So an expired weak pointer is pretty much exactly what I said. Um, Not pretty much exactly what I said, but pretty much as soon as it's out of its scope, you can't really use that pointer anymore because it's deleted, so it's expired. So you can't be like, yo, um, shared pointer, copy this weak pointer, uh, but because like it's not gonna work. So you would have this bad weak PTR, and then in that code you'd have a try and then a catch bad weak PTR, and then it would catch it. So yeah, that's pretty much it. See ya.